Okay, now I am recording, and if anybody wasn't here last time, don't talk while I'm recording. Okay? It's privacy laws and stuff. Can't use the video if you talk. Okay. Then talk all you want to when the video's off, ask questions. Point out my mistakes, whatever it takes. Okay, so we've got this graph. It says profit in millions and widget price. We're measuring widget price here. We're measuring the profit in millions of dollars. We've got a company that's selling widgets. If you sell widgets for a low price, which would be over here, you don't make much money. Matter of fact, if you don't put the price at least here, you're going to lose money. Right? Because any point between here and here, you're going to have negative profit. And that's a loss. Okay. If you put the price too high, you're not going to sell many widgets. Okay. Just a little beyond this point, you're just not selling any widgets. You're not making any money at this point because there's no profit. Okay. Now maybe you're a startup and you got to build market share and you got all kinds of decisions to make on what price point is going to work for you. You at least want to put the price higher than what it costs you to produce the widgets. Okay. And you want to put it somewhat higher than that. So you want to estimate where the peak of this curve is. Because that's going to give you the widget price, gives you the maximum profit. Okay, so question I ask, okay, what's the 16 mean? Okay, well, got an answer. Kind of tentative, but it was right. Okay, should have said it more forcefully. That's all. Now, okay, so that's a widget price. Well, that's because X measures the widget price and 16 is the X coordinate. So X equals 16. It's a widget price. And this is a subtlety, but make sure you think about it for every point. On this dotted line. All right. Well, now let's see if you can tell me what that 8 means. Okay, so we had a question. It's a really good question. Well, what if you take money out and do this and do that and the other thing? Well, this is a model. And this model basically assumes that obviously the more you charge, the more money you take. And that'd be a straight line graph. Okay, the more you charge, the more money you take. Right down. Whether you understand that totally or not, you will. Okay. And then you kind of make an assumption, well, the more I charge, the fewer people are going to buy it. And I think that's probably kind of a straight line. The more I charge, fewer people buy it, there's your line. Okay. Those lines have equations. You multiply the equations for those lines, you get the equation for this. Okay. That's all I'm going to say about it now, because we've got to learn a good bit of stuff before we can really understand that. But that's where it is. You know, it's not really hard, but we want to study linear functions and quadratic functions and see exactly how that model comes out. It's a model that's frequently used in applied calculus courses and in full-on calculus courses, because there are a lot of ways it can be adapted for all kinds of fields other than business. Okay, these models are probably the most common models in the human effort to understand the universe. Okay, including business, including astrophysics. Okay, so now the question is, what's that 8 mean? And we got an immediate answer. It means y. Okay, because that's your y coordinate. Okay, so well, there's your y coordinate. So let's just go ahead and draw a horizontal line here. Y equals 8. That means what? And somebody else said, well, that's your profit. Because it says, why is the profit? Okay. So this says. Y equals 8 on this line, your profit is 8. Meaning $8 million. At this point, price is $16, let's say. Profit $16. That's their price is $16. Profit is $8 million. Okay. Now my question is. What price would you want to charge to get the maximum profit? If all you had was this badly drawn graph and this information and nothing else, what would your estimate be of the price you ought to charge? The first thing we got to do is identify the point where the maximum profit is. I think most of you saw where that was because a lot of you, about half the class, have good estimates, had good estimates the first time I looked. Several others came up with good estimates as I was walking around, but okay, maximum profit occurs here, right? Because that's the maximum value of Y. So let's use some colors. So that should be obvious. After you think about it. Okay, so what is the widget price? Because the question was, what's the widget price? And most of you have estimates somewhere between 9 and 12. Okay. All those estimates are good because you didn't necessarily draw the graph exactly the way I did, but my estimate's going to be in that range. So I can draw this line. And what's X on this line? Well, I'm going to scale the graph. And you need to be able to do this too. Once you have a point on a graph, then you can put a scale on the X and the Y axis. So I'm going to scale the X axis. Well, 16 is here. Now 16 is here. Cut this in half. If I did that right, that'd be about 8. Looks like my estimate's going to be 10, but we'll see. Okay. And then we cut this interval in half, we get 4. Cut this interval in half, and we get 12. If we don't need any more than that right now. But now we've got a scale, and we can just read off widget prices. Any point in the graph, we can read the widget price. Okay, oh, we got a question again. Last one was good, this one better be. Okay, hang on a second. Something's blurry up here. Is it me? Is it the board or is it the camera? Am I blurry? Oh, yeah, not too blurry. Let me pause now. I've got to show the thing a picture to get it to focus. Okay, I think we've got the board to focus again. Can't control the camera. We should have a camera that gives me a fixed focus. It's a great camera. Really, really good camera. It's got that little flaw. everything does. Okay, the question was, well, if there's a recession and, you know, consumers behave a little differently and so forth. And you're out thinking me already, so stop that. But, no, very good, very good. So yeah, those are things you want to think about, not changing your model. Yeah, probably best widget price might lower a little bit. Okay, or maybe you got firm customers that are willing to pay more and you could actually do this because the other people aren't going to buy it no matter what you do, because they don't really need it. Okay, and all kinds of things you can think about. So that's really good. Okay, so anyhow. So we've got this. What other information do we have from this point? Well, we know that y equals 8 here, don't we? So now we can scale this axis. Okay, now if we've got 8 here, and we can see that 16 ought to be up about here, a little above my arrow, but still we can kind of see, right? So go ahead and scale that axis for me. Okay, what I'm saying looks good. You want to put numbers on the scale. You want to scale the graph once you have enough information to do it, okay? Because then you can just read things off. And you very quickly, from what I'm seeing, you're going to very quickly get the skill to do that. Okay, you've already pretty much got it, but you're going to get even better at it. Okay, so we've got 4 here, and we'd have 12 here. And then, you know, here's 2, here's 6, here's 10. Here's 14, okay? We want to scale, okay? So 2 things you can do with a graph. First, you identify what the points mean. And this, if you're given a specific point, what does that specific point mean? Because that gets you thinking. Then you put a scale on it. You know that whatever this is going to be the number you put here. And whatever this is going to be the number you put here. Okay. Now it's kind of a good idea to scale the graph with powers of 2, 4, 8, 16, 32, 64. Just keep multiplying by 2 because it's easy to cut those numbers in half. Okay. And you can cut things in half pretty accurately. We all are doing pretty well with that already. Now that's how you do it with a hand-drawn graph. Of course, if you have function, you can crunch the numbers and you can do the algebra and the calculus. Okay. Now that's what we're going to learn in the course, but first let's understand graphs. And just to give you a preview, and hopefully I'm not going to scare anybody away because this isn't too hard. It just looks hard if you don't know how to do it. Okay. I can estimate this thing is 0 when x equals, we'll say when x equals 1, because I don't want to use fraction, that's more like 1.5. And it's 0 when x equals 20. So we got the formula. Because this is, let's say 1, and this is 20, we do x minus 1 times x minus 20. Okay. That gives us a function that's going to be 0 when x equals 1, right? If x equals 1, what's this equal to? X minus 1 is going to be 0. And that's going to be multiplied by everything else. It's going to give us 0. That makes sense? You don't have to know how to use it right now. I'm just planting a seed that you want to think about. And if x equals 20, well, if x is 20, 20 minus 20 is 0, and this is multiplied by all this, so that's got to be it. Okay. And also, A equals A times 16 minus 1 times 16 minus 20, because if X is 16, Y has to be 8. Okay, I'm not going to ask you to do this. Not yet. So I'm going to go through it kind of fast. I'm just giving you a preview of what we're going to go over about the next month. Okay. Okay, so 8 equals this. Well, 16 minus 1 is 15, 16 minus 20 is 4, and 15 times 4 is 60. So Y equals 8 over 60, which is 2 over 15. Now I know what the equation of this thing is. It even gets better than that. I don't want to use up a whole lot of good board space, but I want you to understand why we're doing this and why we're dealing with the graphs rather than the algebra right now. So we can build the algebra, because the algebra is kind of challenging. If you understand what the algebra is telling you and understand what it means, then the algebra gets a lot easier. Okay, well, so now we know that Y equals 2/15 of X minus 1 times X minus 20. And then we can multiply X minus 1 times X minus 20. And Y is 2/15 times X squared minus 21X plus 20. That's just multiply binomials, use a distributive law, and we'll do that. We won't do it this fast, do it so you'll understand it, but a lot of you do. Okay, just multiply this by this. Use a distributive law and it comes right out. But people are fuzzy on the distributive law typically, at least, a large portion of any pre-calculus class at this point is. Okay, so well, let me. Okay, 2/15 of 21. 21 is 7/5. So 2/15 of 21 is 14/5. And that's approximately 0.13 X squared minus 2.8X plus 20, so it's terribly low. Oh yeah, they got the 20 back here. Okay, well, you analyze this function. And Y's maximum if X equals 2.8 over 2 times 0.13. This divided by 2 times this, for reasons that you'll understand in a month. Okay. And that's approximately equal to 11 point. Oh, come on now. About 11 and a half. I have to do better than that. But, okay, so if those two linear functions multiplied give you a function that goes through this point, okay, and has zeros here and here, that function should have a maximum when X is about 11.5. So that would be over here. I did draw a perfect parabola, and I fudged an estimate here. Okay, so for reasons, it's not all that close to the X equals, I never did make my estimate, but it's obviously 10. So this is pretty close to my X equals 10 estimate, if I can find my green saw. Okay, so at this point, X is 10. That's what we get from the picture. And the reason we're doing the pictures is I don't have to explain all this to you in the first day. Okay, that makes sense? If you understand the pictures, you understand half of it. Okay. So the pictures are where we start as we develop some maps. Now you're going to have an assignment. It's either run fractions or exponents. Yeah, you got two assignments. You got one due. Actually, I've got the thing due today, but it's not going to be. So one's going to be due on Saturday. The other's going to be due on Monday. And then there's an assignment on the packet that I gave you. Packet that I gave you is just graphs. This assignment is make sure you can add fractions. Make sure you understand exponents, okay? And, you know, I expect maybe be a little fuzzy in there, so maybe address a little bit of the algebra part. Okay. So get kind of an idea. Graphs can be important, and the ability to interpret graphs can be really relevant. Well, hopefully you got the idea, but we're gonna a little further better. That's one model. There's another model. Okay, here's another graph, completely different kind of function. I'm going to ask you to do that graph. In this graph, X equals average speed. And Y equals the time it takes to make some trip up the road. Okay. And I'm going to put a point on this graph. Oh, let's say about here. And the coordinates of this point. Their speeds in miles per hour. And the time is going to be in hours. Okay. So I'm going to put the point. $38. Well, okay. And so a 30 mile per hour trip takes 12 hours. Now, there are many ways to say it. Somebody said it better than that. Okay. Would even make brief statement. Or you can make a bigger statement, depending how much you want to say, but that's the minimum that it boils down to. You got to at least have that. Now, if you mixed up the 38 and the 12, well, it's, you know, you're not going to do that for long. So just take a lesson. Okay. Now, so what I want you to do is now estimate How long it's gonna take it? 20 miles an hour. Okay, so, we want to go to 20 miles an hour, right? First thing we want to do is scale the graph. Okay? That usually should be, as soon as you have the coordinates of a point marked on your graph, set up a scale. So I'm going to scale the graph and I'm going to say, well, let's see. Here's 38. There are two things you can do. You cut 38 and a half and get 19, right? And what is going to be pretty close to 19? Or you might want to just say, well, if that's 38, 40 is just a little tad bigger than that. So 38 is almost 40. So right there's 40. Then I can cut that in half and I get 20. And then in here, halfway, I can get 30. And down here, I can get 10. And I can divide it up even more than that if I want to, okay? So start by scaling the graph. That's my best advice. Although a lot of you got really good answers. And you don't have to use even numbers, but if there's a nice number close to the number you got, it's easy to divide several times. Not a bad idea, okay? And powers of 2 are often helpful. Turns out 40 is a good number to use though, okay? And then over here, I've got 12. But I can live with 12. I can cut that in half and get 6, and I can cut that in half and get 3. And then I can double 12, get up here to 24. And I can cut the interval from 12 to 24 in half, and that's going to give me 18. Then I could have 21 and 15. So now I've got some useful numbers on my axes, and then that makes it much easier, okay? Now you can shortcut it. Okay, and a lot of you did and did a good job of it, so that's fine. In general, I'd recommend trying to do a good scale. And it doesn't have to be a multiples of 10, multiples of 3 are just fine, because now I can go to 20. And I can say, and as I think everybody pretty much did this, I've got 20. And here's my line where x equals 20. And then I project over here. This is my line where y equals 18. So this point would be 2018. Okay. And most of you got, so we had, I think the highest number that's over 24. It depends on where you put this point, right? You move it over just a little bit, this graph's getting pretty steep. It's easy to get up to 24. And if you didn't draw the graph exactly the way I did, and you wouldn't, okay, it's not a bad estimate, okay? 15 isn't a bad estimate, okay? Nothing's really a bad estimate if you do these lines and have the right general shape of the graph. Now, to get a really good model, you have to have just the right shape of the curve. Okay. I don't think I have really the right shape of the curve. Although I've drawn this curve a lot, I'm probably not too far off. I can check myself. If you drive 18 hours at 20 miles an hour, how far do you go? Multiply 20 miles an hour by 18 hours, you get 360 miles. Now, if this comes out right and if it doesn't, it'll be really weird. Okay, because it's hard to draw this thing freehand and make it exactly right. It's not exactly the right curve for this model, but it's not too far off. If I multiply 38 by 12, well, 38 times 10 is already 380, which is more than 360 I get up here, right? And we're not changing the trip, so this isn't quite right. And then I add 68 to that, I get 448 miles if this is right, and I get 360 miles if this is right. So they're not both right, which means my curve wasn't quite right. Or either that or my lines weren't quite right. My estimate wasn't quite right. Well, again, just like I showed you before, you do some algebra. It's actually a little simpler than the algebra I showed you there. If you know how to accurately construct that graph, you get a graph that gives you good estimates. And you can then relate that to the function. It's actually fairly simple algebra in the case of this function. Okay. The algebra for the one I showed you first, the profit function, which I chose to start with because everybody's interested in making profits. Okay. Algebra is a little more complicated though. Not too complicated. We'll get it in the next few weeks. How many of you remember seeing the quadratic formula? That comes down to that. Just have to know how to use it. And some of you do, because I know I've had to do class before. Okay. Okay. Well, that's two functions. Now there are three toolkit functions that we start with. There's that one. Well, not that parabola thing. There it is. There's this one, the parabola shape. There's this one. It's a reciprocal function. Okay. And the one actually kind of some ways the easiest to draw, but maybe hard to draw accurately until you know what's going on. So here we've got another one. These are time in years. Back to money. Although this model also works for populations, ecosystems, and all that stuff. But we have this. And we have a graph that looks something like this. Okay, so I'm going to say this is the value of investment in thousands of dollars. Badly drawn dollar sign, okay? So can you start by scaling the x-axis and scaling the y-axis? I don't know if this is going to look blurry. Start by sketching that graph as best you can. And scale the x-axis and scale the y-axis. Yeah. Maybe your investment is this wonderful picture here. It's already worth thousands of dollars. Think of what it's going to be worth in 40 years. I don't even know where the thing came from, but the lines are kind of distinct and it helps the camera focus, so I use it. Okay, I hope we can move this picture here. Sort of get tired of looking at it, but it works. Okay. So what we do here, there's 40. There's 70. Now, we want to divide these intervals in half. Okay. Which means that half of 40 being 20, well, that would go here. Halfway between 0 and 40. We'll be careful about that. Okay. And then divide up to 20. Half of 20 is 10. And then we can see that 30 goes halfway between 20 and 40. Okay, just think about the numbers, make sure they make sense. Make sure the scale makes sense. Okay, now we could divide 70 up. Half of 70 is 35. Of course, half of that 17 and a half. Half of that is 8 3/4. And you don't want to get into those fractions if you can help it. So what I'm gonna say is, well, if that's 70, where's 80? Is it up here? Down here? Tell me where to stop. I'm gonna start here and tell me where to stop for 80, right? And don't say anything because we're recording. Just throw something hard at my head, so I have to duck. Okay, don't worry, my reflexes are up to it. Y'all don't have that good one on. Okay, actually, you probably do. Ready? Just indicate, say, yeah. Actually. Yeah, I don't, clap your hands. Okay? Or beat on the table. With your fist, not your head. Okay? So, tell me where to stop. Make a noise. Okay, that's pretty good. Several of you agreed that 80 should be about there. Okay, and maybe I got it where you wanted me to have it, but we're gonna go with it regardless. Okay, so we're gonna cut that in half. Now, cut it in half, you just kind of bring your fingers together and say, okay, that looks like half, and then just make sure that's about the same as that. It's a little low, but let's do estimates. We want to make them as good as we can without getting out all kinds of drafting instruments and going overboard on making an accurate graph. We want to make it as accurate as we can, but we want to do it. So there's 40. Divide that in half, we get 20. Divide there with 40, get 80 in half, we get 60. So 70 looks like it's about halfway between where 60 ended up. So yeah, compliments to your eyes. Okay, and then we can divide into towns here, here, here. That's pretty good. Okay. Okay, now, if you did divide the 70 in half, 35 is going to be easy to find, right? But tell me now, what is t when y equals 35? Okay. Now, okay, so what's t when y equals 35? Well, that's pretty straightforward. If you notice that I said y equals 35, because you're used to doing x. Of course, we don't even have an x, we got a t. So we want y equals 35, so we go here to 35, which is between 30 and 40, it'd be about here. And then we come down here. We get something kind of close to 20, but maybe a little less, okay? So here, y equals 35. Here, x equals, I'm going to say 18. No, that's not x, it's 2. So my answer, the first thing I want to see is I want to see these lines. Okay, so I can see clearly what you did, and then your answer and say, you've got time to write it out. Or actually, that's not the right way to write it out. Okay. Now I chose y equals 35 to say, well, this thing doubles between here and here, right? And this tells us that it took 18 years to double. Which tells me that your interest rate is probably somewhere close to 4%. Okay. Now, you won't get that connection till we do the algebra of exponential functions, which is actually easier than the algebra we do in the middle of the course, but it comes closer to the end of the course. Okay. Yeah, got a question? Okay. Okay, very good question. Let's see, that's 3 or 4 really good questions you've asked today. You know, there's a limit. I don't know what it is. Keep it up. Thank you. The question is, I think my investment started at $14,000. Why is there a curve go over this way? Maybe it doesn't. Maybe that's when the investment was made. Maybe that's an investment you inherited from somebody 30 years ago. And you want to start counting when you got it, but it was still going before you got it. Okay. So that's a couple of ways you could answer that question. Okay. Very good. Now, quickly, we've seen 3 graphs. There are 3 shapes. Okay. I can draw these shapes. I can have a graph that looks like this. I could have a graph that looks like this. And the graph could be anywhere on your coordinate axis. Okay. I have one down here. Okay. Those are parabolas. Those are graphs of quadratic functions. Okay. Most often, we're going to see this graph like this, and this part of the graph is often really irrelevant. It certainly doesn't apply to the trip time thing because you'd have a negative speed. That doesn't necessarily mean you're going backwards, okay? Because you'd have a negative time, and you know, interpretation of this wouldn't apply, so it might not be in the domain of the function. These are reciprocal graphs. And we call this the exponential graph. Now we can move these graphs around. Exponential graph could be like this. That would model an investment. We could have an exponential graph that turns this upside down. That could be like the population of fish in a pond. It grows fast when there aren't too many fish to compete, and it slows down when you get to the limits of how many fish can fit in that pond, how much food there is, how much space there is. Okay, so one of the questions you're going to have for homework on the sheet involves drawing graphs of these basic shapes at different points. And we'll see how you do with that. But you have to know what the basic shapes look like. You've drawn them. Now you know what the basic shapes look like. You're not going to have the accurate basic shape, just like my reciprocal graph wasn't totally consistent. Gave me 2 different trip distances on the same model. When you draw the things, they're not going to be totally accurate. Okay, you can still draw them. And you can still understand that they can be moved around because it turns out that that's really important. So on the sheet, starts out with the go upside down reciprocal graph, and this is a profit model. It asks you to do just the same stuff we did. And then the next page, you got this graph. It's accurate at this time. Okay, so if you do accurate estimates, you're going to get consistent results. Then here, you got an exponential graph question, just like the ones I've asked. Okay, so all these things are pretty straightforward. Then I ask a few more questions. So basically, I'm asking you to draw a graph and scale it. Draw it yourself. What we've just done, what you all have picked up really well. Okay. And then make some estimates. And do another one to make some estimates. And then it gets to sketch a graph representing the toolkit squaring function. Okay. Don't do that. That's where it ends. So that's 6 or 7 problems. I can't give you a page number because everybody's pages are different and your numbers are different, okay? But that's labeled 1FA. Top 2. The one that has a 1FA on it, don't do that one. I'll show you how to do that next time, okay? Y'all made great progress. Also, check the assignments in my open math. You're gonna have a couple of them. Fractions and exponents, I think, okay? And there's another one that I kind of eliminated. You know, you wanna make sure you get a good start with those concepts because they're troublesome for a lot of people.